All right, we're going to do a couple examples of derivatives of the natural exponential function, which of course looks like this. Y equals e to the x. Make that x look a little better. And of course we know that if y equals e to the x, y prime equals e to the x as well. So that makes things nice and easy. But sometimes the problems aren't quite that simple. So for example, what if we had a problem that was like y equals 12 e to the negative 2.5x. Okay? Well, y prime equals, well, first we'll keep the constant, right? The constant just stays. Derivative of e to the negative 2.5x is e to the negative 2.5x. Then we multiply by the derivative of the inside function, and there's the inside function, negative 2.5x, so negative 2.5 is the derivative. So 2.5 times 12 is, let's see, 24 plus 6 is 30, right? So negative 30 e to the negative 2.5x is our answer. All right. Let's see. Let's try something more challenging. How about y equals x cubed e to the sine x. Actually, no. Let's not do sine x. Let's do e to the 4x squared. Okay. Well, this is a product. There's two x's, right? So when we do y prime, we're going to do, here's u, right, and here's v. Okay, so the first thing is u prime, so 3x squared, times v, which is e to the 4x squared. Okay, that's u prime v, plus v prime, and here's our e to the 4x squared, so the derivative is e to the 4x squared, times the derivative of 4x squared, which is 8x. Also times u, which is x cubed. Okay? Now, the first term doesn't simplify. 3x squared e to the 4x squared. The second one does. We have 8x times x cubed, so that's 8x to the 4th. And I'm going to put that in the front just because I feel like it. Times 4x squared, and there's our answer. Okay? Another example. Y equals, let's do 6 e to the ln of sine of 2x. Okay? Looks pretty big and hairy and crazy, but we know the property that e to the ln of x equals x, right? Just like ln, this is an e, just like ln of e to the x equals x. So we have something, this isn't working. Something's wrong here. Okay, there's our properties, right? Because these functions are inverses. So here we have e to the ln of sine of x. Well, this function, I'm not taking the derivative yet. I'm just going to rewrite it because e to the ln of something is that thing, right? E to the ln of a thing is that thing. So this is just 6 times sine of 2x, right? So this has become an old problem now. So 6 times cosine of 2x times 2, right? So 12 cosine x. And make sure we note that we're doing y prime now. 12 cosine of 2x. Okay? So you make sure to use those properties. You certainly could have done this with the chain rule and everything, but boy, it's a lot easier if you just simplify it first. So there's a couple examples. Good luck on the homework.